Welcome everybody to today's lesson. Today we're going to start with discussing about algebra. Let's start with the question, what is algebra? Well, a simple definition of what algebra is, it's simply the use of variables to represent unknown values. What are variables? Variables can be any letters or symbols to represent something that's not known. Let me give you an example. If, for example, we had a simple exercise like 5 plus 2 equals. Now, in first grade, you would simply leave this blank and ask students to solve, or simply put a square there, and then you would put in the answer. In algebra, we stop using these squares and we use letters and symbols to represent this value. So an example representing algebra would be the following. 5 plus 2 equal to, let's say we're going to use the letter A. So in this case, A represents the total of 5 plus 2. Now in both cases, that would be the same answer. So 5 plus 2 will give us the 7. Now in the case of algebra, we would say that A has the value of 7 or is equal to 7. Now you might be asking, why are we complicating things? Why do we need to use letters to represent these unknown values where we could just simply put in a square for the unknown value? Well, as you progress further and further into math, there will be more and more unknown values that you need to solve for. So in that case, you're gonna sometimes have to use two different variables to represent two different unknown values that are not equal to each other. So using a letter instead of squares makes this easy, because if you have two unknown values, you cannot use two different shaped squares, although you can, but it would make things a little bit more challenging. So what is algebra? Algebra is simply the use of variables, which can be letters and symbols, to represent any missing values. So this was my first example. Let me give you one more example. The variables don't always have to be your total. They can also be an unknown value before you get to the total. So let's say you already know the total, but you don't know one of the numbers. For example, if I were to use A plus 3 equal to, and let's choose a random total. Let's make this, let's say 11. Now in this case, the unknown value is not your total, but it's actually one of the numbers that you are adding to get to that total. So we just can figure out what this A is by simply asking ourselves, what number plus 3 will give me 11? Well, after a little bit of thinking, you can come up with the answer that A has to be equal to 8, because 8 plus 3 is equal to 11. So the answer was 8. Therefore, A is equal to 8. Let's move on to our next slide. What is an expression? Now I'm going to write two examples here. Let's say 3 plus 4, and over here I'm going to write 3 plus y. Now on the left, and actually on the right, these two exercises are both called expressions. Let me underline that better. They are both expressions. Now the one on the left is simply called a numerical expression, okay? The one on the right is no longer going to be called numerical expression, but it's actually going to be called an algebraic expression. And the reason being, as you might have guessed, because of the use of the variable, this is no longer a numerical expression, meaning you are not only using numbers, in this case you're also using a variable. So therefore this becomes an algebraic expression. Whereas this one, only had numbers in it, therefore it's a numerical expression. But I still haven't defined what an expression is. Well, an expression is a mathematical sentence. For example, 3 plus 4 is an expression. 3 plus y is also an expression. What are we doing here? Here we're adding the 3 with the 4 to get a total. Here we are trying to figure out what this number should be, but we don't know yet what to do with it until we actually either get a total and then we figure out what the missing value is, or we are given the missing value and that way we can calculate the total. Let's move on to the next part. Now let's do some vocabulary. Over here we have an expression. Now what do you think? Is this a numerical expression or an algebraic expression? Well, if you look carefully, this particular expression has a variable. Therefore, this cannot be numerical. So this entire thing is an algebraic expression. Again, an expression is a mathematical sentence where you can see a number, a variable, and a number multiplying the variable. We're gonna be explaining that in just a second. So we have a variable. Now the number in front of the variable, the 5 in this case, it's called a coefficient. Now the coefficient is multiplying the variable. Okay? So 5y, I'm gonna write it over here, is actually equal to the 5 times y. Now you'll notice that for the multiplication sign I did not use that x symbol, I used a dot. And the reason being is because in algebra we refrain from using the x symbol for multiplication because now the x is used for variables. So in order to not get confused, we no longer use the x as the multiplication. We use a dot. As you go further and further along, you will also start using parentheses to represent multiplication. For example, 5 parentheses y. Okay? Now, coefficient is multiplying the variable. Now this 10 that's all alone here is called a constant. Okay? Now, there is another name for the 10. It can also be called a numerical term. Now the constant can also be referred to as the constant term. So pretty much any number that's all alone in algebra is simply referred to either as the constant term, or numerical term. The letter, of course, it's known as our variable. The number in front of the variable is referred to as the coefficient, and it's always multiplying the variable. And the sign in the middle, we should all know what that is. Besides being an addition, that's also called the operation. So this is the operation, and in this case, that's an addition. Let's move on to the next slide. Now, expression versus equation. On the left here, I'm going to write an expression. Let's say we have the expression x plus 4. Now, as of right now, this is simply called an expression. You have the variable x plus the variable 4. Now, on the right, I'm going to write the same expression, but now I am going to make it equal to a value. Let's say the total here will be, let's keep it easy, let's make it a 10. Now this is again called an expression. To be more specific, this is an algebraic expression. This one is an equation. Why? Because it contains the equal sign and the two sides are equal to each other. That's why we get the name equation. So what is an equation? Well, an equation is an expression equal to another expression. Now you might say, hold on a second. The 10, I thought it was called a constant or a numerical term. Yes. Now an expression can be a single term, two terms, or many terms. For example, a 10 on its own can also be called an expression or a numerical expression. And then when I add x, now this becomes a two-term expression because it has two separate terms, a numerical term and an algebraic term. Okay? And I could keep on adding more and more, or let's say we subtract by 5. Now this expression has three terms, the 10, the x, and the 5. It is still an expression, and it is an algebraic expression because it has the x in the middle. Now the equation, as I said, is an expression equal to another expression. Let's move on to our next slide. Now let's consider the following expression. We have 5y plus 10 minus x. How many terms are there? Now here's how you can identify terms right away. A term could be a number, a variable, a number multiplying a variable. Okay, so let's look carefully here. It can be a grouping of a number times a variable, or a variable on its own, or a number on its own. And the terms are separated by an addition sign or a subtraction sign. So if we look carefully, you have an addition sign here, and you have a subtraction sign over here. Now when you circle those, you will notice that you're going to have three separate terms. You have the 5y, which is an algebraic term. Then you have the 10, which is a constant term or a numerical term. And then you have the x here, which is a variable term, which can also be called an algebraic term. So we have three separate terms. So to answer the question, how many terms are there? The answer would be 3 terms. Okay. Are there any constants? Well, what is a constant again? A constant is a number that's totally by itself. If you look carefully, the 5 is next to the y. The 5 is multiplying the y. That is not a constant. That is called a coefficient. The 10 is all by itself because it's separated by the addition in the front and a subtraction behind. So the constant is the 10. Are there any constant? The answer is yes. And then we can put a comma, 10. Or we could write a quick or short sentence saying 10 is the constant. Are there any coefficients? Again, the coefficient is the number in front of the variable. If you look carefully, you do have a coefficient, and that coefficient is the 5. Okay? The answer here would be yes, the 5. Now, if you look carefully, you have another variable here, the x. Now you might say, okay, but there is no number in front of the x, therefore the x does not have a coefficient. There is a special coefficient, the 1. Now, if we take 5y, we know that the 5 is multiplying the y. But what it is also saying is that you have 5 y's that are unknown, meaning you have 5 different values that are unknown and they are equal to each other. So instead of writing it as y plus y plus y plus y plus y, we simply write it as 5 times y. So we have 5 y's. Now the x, how many x's are here? You have 1x. So you can technically write that as x times 1 or 1x. But we all know that 1 times anything, it's the same thing or itself. So 1 times x is simply going to give you x. So when we write an expression, the coefficient of 1 will always disappear. Think of it as an invisible coefficient, because 1 times anything, it's the same thing. So you don't need to write the 1 in front. However, you will need to remember it whenever you are subtracting or adding terms that are alike, which we'll get to in a later lesson. So to answer the final question, yes, 5 is a coefficient, and also 1, the 1 in front of the x. Now, let's look at our final scenario. Here you've got a single term, which is an algebraic term. Okay. You also have an algebraic term here. Now, they are both single terms and they're both algebraic terms. Are they expressions? Yes, they are. They are a one-term expression. So technically, you could also call them both algebraic expressions. Now, what is the difference between these two terms? Well, I've already told you guys that the number in front of the variable, the coefficient, is always multiplying the variable. So 3x can be also written as 3 times x. Now again, for multiplication, I use that dot instead of the x symbol, because if I were to write this symbol, it will look quite confusing, wouldn't it? That's why we refrain from using that symbol to represent multiplication. So 3 times x. Now in this situation, we have an exponent. So the 3 here is called an exponent. Now, unlike coefficient that multiplies with a variable, what an exponent does is it tells you how many times to multiply the variable itself. Here's what I mean. If I were to write the expanded form of x to the third power, I would write that as x times x times x 3 times. So the unknown value is multiplying itself 3 different times. Whereas here, the unknown value is getting multiplied by 3. Now, at first, your first thought might be, well, shouldn't they be equal? Since you have 3x's multiplying here and here you're multiplying by 3, we should get the same answer. That is not the case. Let's do a test. Now, one way to test whether these two expressions are the same is by simply picking a value for the x. Let's say the x is equal to 2. Alright, so now 3 times x will become 3 times 2. Whereas in this case, again, the x will also be 2. This one will become 2 times 2 times 2. Well, what is 3 times 2? 3 times 2 is 6. Now to do this, I'm going to start with the first two 2's to the left. 2 times 2, which is 4, times the third 2 will give me 8. So these two values are not the same. Therefore, this expression and this expression are not the same. So again, the difference between a coefficient and an exponent is that the coefficient simply multiplies the variable, the number multiplies the variable, whereas the exponent is telling you how many times to multiply that variable. One last thing before we end this lesson. What I'm going to do is I'm going to show you a different way to write 3x. So let's erase the example below. Okay. Now another way to write 3x is by writing it as an addition. 3x is also equal to x plus x plus x. Now, if you look over here, these are not the same because these x's are multiplying each other. whereas these ones are adding each other. Now, if you didn't know, what multiplication is simply repeated addition. If you say this out loud, you can see that you're going to get the multiplication. Here's what I mean. You have x plus x plus x. You have x 3 times. So x 3 times. That's how we get times in multiplication, because the x is being repeated 3 times. So multiplication is repeated addition. It is not repeated multiplication. Repeated multiplication gives you an exponent. Now let's test this out to see if this is actually true. Let's again use the 2 for x. We already said that 3x is going to be 3 times x, therefore this will be 3 times 2. And 3 times 2 will give me 6. Now let's see what am I going to get over here. Now here, let's bring down the equal sign here. Here I'm going to have 2 plus 2 plus 2. Again, I'm using the 2 because we chose to use 2 for the x. So that's 2 plus 2 plus 2. If you add the 3 2's together, you're going to get 2 plus 2 is 4, plus 2 is 6. You can see that this side is equal to that side. Therefore, 3x is actually equal to x plus x plus x. In fact, you can use any other value for x. You can make x equal to 4, and you will see that these sides will continue to be equal to each other. Now, let's think about some of the definitions. What did we learn about today? Well, we learned about algebra. Algebra is the use of variables in math to represent unknown values. Think of it as a placeholder. Another definition would be coefficient. Coefficient is the number multiplying the variable, and it's located in front of the variable. Then we have the variable. That is the letter, or it could be a symbol representing an unknown value. Then you have the operation, which could be addition or subtraction for most expressions. And then you have the number by itself, referred to as the constant or constant term. Another name could be a numerical term. Now, if you take the entire expression, the coefficient with the variable, with the operation, and the number, which is called a constant, you have what we call an expression. If there is a variable in that expression is called an algebraic expression. So this concludes today's lesson. Thank you so much for joining me, and make sure to wait for lesson number 2, which will be coming out soon. If you enjoyed the video, please make sure to like and subscribe. Also, please make sure to leave a comment with any suggestions and any recommendations for a future video. Thank you so much, and have a good day.